I first of all compliment all the teachers who have joined live on this session, and I thank IIRS for organizing this wonderful session or course, which will be very useful for school teachers who are attending this through the program called SETU. So it's really a SETU between IIRS and all the school teachers. My lecture will be more focused on the whole solar system, the planetary science aspects, the planets, the comets, the asteroids, the moons of planets, and what we know about it, a little bit in general, so that they can use this information for teaching their own students in the schools. And in the end, I will just talk on a few slides about the various missions which India has undertaken. Currently, I'm talking to you from Ahmedabad, the institute called Physical Research Laboratory. And this institute is having 4 campuses, which you are seeing in the bottom of the slide. There are 2 campuses in Ahmedabad, 1 campus in Udaipur, and 1 in Mount Abu. So PRL is called as Cradle of Space Research in India, essentially because all the space science activities in India started under the leadership of Dr. Vikram Sarabhai, who established the PRL in the year 1947, the year India became independent. So when we talk about rocketry program, you talk about satellite program, you talk about ballooning program, or any application program, it all started under the leadership of Dr. Vikram Sarabhai. And you can see Dr. Vikram Sarabhai along with our former President of India, APJ Abdul Kalam, who was actually working in PRL under the leadership of Dr. Sarabhai, and he was sent by Dr. Sarabhai to Trivandrum near Thumba to start the rocketry. And the first rocket launch, which took place from Thumba, which is a small village near Thiruvananthapuram or Trivandrum, the capital of Kerala, has experiments developed in physical research laboratory. So PRL essentially develops various experiments for doing science, including the first rocket launch on 21st of November 1960. Now let me talk a little bit more about Dr. Sarabhai, whom you must be well aware about it. He was a distinguished scientist, founder of PRL, but he is actually the father of Indian space program. So PRL got established in 1947 and ISRO got formed in 1969. So after almost like 22 years of PRL formation, only ISRO came into existence. And if you look at the slide which shows about the foundation of PRL campus, he called on his guru, Sir C.V. Raman, to lay the stone for the foundation of PRL. Because C.V. Raman, Dr. Sarabhai used to consider C.V. Raman as his guru, and you know C.V. Raman, the Nobel laureate of India. And once the campus was ready, it was then Prime Minister Pandit Nehru who came to inaugurate this building in 1954. Okay? So this is a campus which is more than 75 years old now. And it got developed and then expanded upon into various campuses. So now you can see the campus of Mount Abu in Udaipur, Mount Abu in Rajasthan, where we have telescopes, and also the Udaipur Solar Observatory in the middle of the Fateh Sagar Lake, which is also a part of PRL. And more recently at Mount Abu, we have developed another telescope, which is a 2.5 meter telescope. So those who are near the Mount Abu or in Rajasthan or Gujarat are interested to visit this telescope facilities, they can write to me and we can allow you to visit these facilities, and you can actually gain more and even take your kids to showcase these facilities of how science is done using these telescopes. Now, talking about PRL, as I just mentioned, that we had already completed 75 years. And in this celebration, we started a Vyakhyan series, which we called PRL Kamrit Vyakhyan. And every Wednesday at 4 p.m., we used to have a Vyakhyan, starting from 4th of August 2021 till 5th of January 2023. And you can go to this YouTube channel of PRL, which is given in the bottom. which gives all the 75 episodes of PRL Kamit Vakyan. But after 5th of January 2023, we started it as a monthly series or monthly Vakyans. And right now, this series is going on. Every month, we have one Vakyan, which is happens on any of the Wednesdays. So you can go to this YouTube channel and listen to many of the Vakyans given by experts, secretaries, Nobel laureates, and distinguished personalities in different domains of science, technology, education, law, business, management, sports, culture, arts, any domain, whosoever is really distinguished in their fields, they have called them to give the Vakyans. And Dr. Sarabhai actually has a crater on the moon. And you are seeing here one of the images taken by the Chandrayaan-2 terrain mapping camera, which shows the Sarabhai crater. It is a big crater of about 8 kilometer diameter and 1.7 kilometer deep. And you can actually see this crater because it's on the near side of the moon. Near side means the side which we always see of the moon, and far side is the side which we never see from the Earth. So if you have a small telescope, you can actually see this crater named after Dr. Vikram Sarabhai. Now, this logo you must be seeing in many of my slides. And I want to tell you the significance of this. On the left side, you are seeing a circle and a dot in the center, right? So this is the symbol of the sun. On the right side, you are seeing a circle and a cross in the center. This is the symbol of the earth. Now, in addition to this, you have two lines, which is joining this, and a big circle, right? So if you translate that, what it actually means, or what the logo of PRL means, it means PRL research encompasses the earth, the sun, immersed in the fields and radiation, reaching from and to infinity, all that man's curiosity and intellect can do. So that means research in PRL encompasses all the fields which is there for human to explore. It means from the core of the earth to almost like end of the universe. And if you look at how PRL has actually contributed, I will not go into details of each of these personalities, but I just mentioned about Dr. Abdul Kalam, who was working in PRL. In addition to this, you must have heard about the name of Professor U.R. Rao, who is called as the satellite man of India, who started the satellite program in the country, and Dr. Kasturirangan, who recently expired. And he was instrumental in developing the further satellite program in the country, but also you must have heard about NEP, New Education Policy. And he was a chairman of the commission who was establishing or making the policy for the new education. In addition to this, there are many other colleagues who have contributed, but both of this, Professor U.R. Rao and Dr. Kasturirangan, did their PhD in PRL. So they are the distinguished alumni of PRL, in addition to all those whom you are seeing over here, and they have been the directors of various national institutes in the country. Now let me talk about solar system. When you talk about solar system, we see this picture where you are seeing the relative size of planets and the sun. I hope everybody is getting this, my voice and the slides, right? Can anybody confirm?
Yes, sir. For us, it is.
Okay. Can you also cross-check at other places that everybody is getting this?
It's there, sir. It's there. It's coming nicely. Absolutely.
Okay. Okay, perfect. Thank you. So when you see this slide, you are seeing on the left side the sun, a small part of the sun. And then you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And this is not as a relative distance. It is only the relative size. And that shows that we have two classes of planets in our solar system. The inner part, that is Mercury, Venus, Earth, and Mars, they are much smaller in size compared to outer part of our solar system, which consists of Jupiter, Saturn, Uranus, and Neptune. Okay. Now, we also know that the way to remember this order is telling a mnemonic, which is like, my very excellent mother just sent us 9 pizzas. But where actually the first letter is talking about the planet. So Mercury, Venus, very excellent is Earth, Mother again is Mars, just is Jupiter, Sand is Saturn, Earth is Uranus, and is Neptune, and Pisces are Pluto. Now this mnemonic, or the way to remember, has changed now because Pluto is not considered as a planet. And so this rhyme will become what? My very excellent mother just send us noodles. So instead of 9 pizzas, we are going to get noodles. Okay. So this is just to be a little bit of fun for the kids and the way to remember the planets. Now, what is planetary science and what is a planet? How do we define a planet? And why Pluto is not considered as a planet now? So that means there has to be a definition of planet, and Pluto is out of this definition or is not fulfilling this definition, and that's why it is not considered as a planet, right? So we say a planet is a celestial body which orbits around the sun. So all planets are orbiting around the sun, including asteroids. They should have sufficient mass for its self-gravity to overcome the rigid body forces so that it becomes in hydrostatic equilibrium, which in turn means they should be round in shape. So Pluto fulfills that also. But the third definition says that a planet should have cleared the neighborhood around its orbit. And this definition is not fulfilled by Pluto, essentially because there is a small satellite of Pluto, which is roughly half the size of the Pluto, and it is called Charon. Because of which, Pluto is now called as dwarf planet or minor. Now, if you look at this terrestrial planet or inner planet, we say Earth and Venus is same size, Mars and Mercury, Mars is roughly half, Mercury 1/3. But when you compare them with the outer planets, which I showed you in the first slide itself, you will see that Earth is the 5th largest planet, right? Jupiter is the biggest, then comes Saturn, then Uranus, then Neptune, and then comes the Earth. But now if you compare this with Sun, where do we stand? We are a small dot, right? And on this small dot, now you imagine your own state, your own city, your own house, and yourself. So how small we are with respect to the size of the sun. So this is just to give you a feel of how big these objects are and how small we are. Now coming back again to the solar system, and this again gives you the same picture which I showed you earlier. But now I'm showing you also, in addition to Pluto coming into the category of dwarf planet, we also have asteroids, we also have comets, and we also have planets now discovered beyond the orbit of Pluto, like Hume, Makemake, Eris, and things like that. So now if you want to study the whole solar system, you will say that in the trans-Neptunian orbit, that is beyond the orbit of Neptune, we have many other objects which is known now, including, of course, Eris, Makemake, Huma, Sedana, Fire, Varna. And here you can also see Pluto with its small, substantially big moon or satellite called Charon. Okay, and then there are, of course, many few others moons of the Pluto which is also seen. And these all consist of objects which is beyond the orbit of Neptune, and that's why they're called as trans-Neptunian. Now let us talk a little bit about asteroids. Asteroids, we call there is a belt of asteroids which is in the orbit between Mars and Jupiter, but they come very close to the Earth also, and they are called as near Earth asteroids. And they are quite dangerous because in case they come into our own Earth's atmosphere, then and they survive, they can come and hit, as it has happened 65 million years back when we have the extinction of dinosaurs due to a big asteroid coming and hitting the planet Earth. Now, biggest of these asteroids is called Ceres, which is about 1,000 kilometers in diameter, and it is the most massive object. You can say about 1/3 of the total mass of the radiation belt or asteroid belt actually is in the Ceres, which is one of the biggest and the largest asteroid. And then if you go into asteroid and try to understand them, they look like some very different shapes. Some of them look like potatoes. And even these asteroids have moons or satellites of them. And their body looks to be cratered, as you see over here. So there are impacts which is happening, which is creating craters. And even the smaller objects, any of the small objects will also have craters on their body. Now, talking about their different shapes, we are able to see this different views of the same asteroid from different angles, which in fact suggests that it all depends upon how you are looking at a given object. Eros is another asteroid, but it is the second largest near Earth asteroid. I mentioned to you that near Earth asteroids are more dangerous, and therefore we keep a vigil or continuously observe the near Earth asteroids. Let me talk a little bit about comets, which are very small objects. Their sizes could be a kilometer to a few tens of kilometers only, but they can become a huge object once they come closer to the inner part of the solar system or closer to the sun. Essentially because comets are believed to contain a lot of ice, which is like volatiles. And once they come closer to the sun, because of the heat, these volatiles escape. Or you can say it is not evaporation, it is called conversion of ice to directly gas phase, called sublimation. So sublimation forms this ice to gas phase, and then because they are moving with a high speed around the sun, they form a long tail. And this tail can be even 1,000,000 kilometers long. So when we say that I can see a comet in the night sky, that means this comet has a huge long tail, which I'm seeing. And they are also believed to contain most pristine material, essentially which was available at the time of the formation of the whole solar system. So that means I can use comet as a sample for understanding how the whole solar system has formed. Now, if you look at the size of this coma, which I am talking about, of a comet, which is actually the atmosphere of the comet, it can be as big as the size of the sun itself. And here you are seeing the comet homes and the size of the sun. So because of this long tail or the huge coma which get formed around the comet, their size can be huge. Now let me quickly tell you of how do we scale the whole universe. Okay, and I will do it pretty fast because otherwise it will take a long time. So if I see a small garden and a lady sitting at the bench, I hope you can see that. Now if I keep on zooming this by a factor of 100, okay, what happens? I see a small part of a city. I zoom it further, I see almost a state, and the dark lines which are seeing through in the red patches is nothing but an IR image of a river which is flowing through the state. I zoom it further, I am seeing the whole earth. So in the 3 steps of 100, from this picture of a garden, I'm coming out to the size of the earth. And if I do it one more time, I see moon, and I do it one more time, I am seeing sun-earth distance. So sun-earth distance is called 1 AU, which is 1.5 into 10 power 8 kilometers. So that means when 5 steps from this garden, I'm reaching the sun-earth distance. I'm zooming it further. So 1.1 astronomical unit, because 1.5 into 10 power 8 is the mean distance between sun and earth. I jump it by a factor of 100, I am crossing the whole solar system, right? And if I zoom it further, I see nothing around the sun, that is our solar system. But I zoom it further by a factor of 100, I am seeing few other stars. So that means the nearest star is several thousands astronomical unit away, or you can say about few light years. Zoom it further and further, I am seeing the whole galaxy, which is the galaxy in which our whole solar system is, which is called as Milky Way galaxy. Now what happens if I zoom it further? I see few other galaxies around the Milky Way, and beyond that, and abstract. Means I have actually crossed the whole universe in 12 steps, starting from the size of a garden. Because right now we know that the whole universe is about 14 billion years, 14 light years. So now let us come back and talk only about our solar system, right? So we have the sun in the center, and then we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay? Now, little bit about Earth, just to give you a context for planets. So Earth, we know it is tilted by 23.5 degrees, right? And that's how we have seasons. So season is because of the tilt of the Earth. But what about tilt of the other planets? You see it over here. If you look at Earth, 23 degrees, Mars is roughly similar to Earth. We can also say Saturn is also somewhat closer to that of Earth and Mars, 27 degrees. But Jupiter, the biggest planet in the solar system, is almost vertical, just 3 degree tilt. What about Uranus? Its tilt is like 98 degree. That means its poles is looking towards the sun, right? And if you look at Venus, 177 degree, that means it is rotating ulta, reverse, right? So that means there are planets in our solar system which have a very, very different tilt. And that means there could be much different kind of seasons present on these planets. But when we talk about Mars, we say it is very similar to the Earth, right? And it has more or less similar seasons that of the Earth. It has what it called a lot of terrestrial rocks and things like that. And it is also believed that Mars could have been wet and hot and wet in the past, but currently it is cold and dry. Now let me talk about masses of the planets. And this is just a graph to tell you in terms of the scale of how do you feel that. Let us put Earth as 1 in terms of the mass. Then we will say Jupiter has the largest. Next comes Saturn. And then we have Neptune and then Uranus, right? And also we could see what happens for Venus, Earth, which are called sister planets. And then the mass of the Mars, which is roughly half that of the Earth, and things like that. So the massive one is Jupiter, and then comes the Saturn. But if you look at the length of the day, length of the day means the planet spins on its axis, and one complete rotation on its axis called length of the day. Now, length of the day, if you look, keeping Earth as 1, it is not Jupiter, it is Venus, which has the highest length of the day. It takes 243 Earth days for Venus to spin on its axis. That means its days, or I should say day and night, are much longer. It could be 120 Earth a day as a day and 120 Earth night as a night on Venus. That means you work for a very long time and then sleep for a very long time, right? And if you look at Jupiter, how much it is? It is just 10 hours. A huge planet spinning on its axis in 10 hours. Earth taking 24 hours. Venus is taking 243 Earth days. Okay, so that means there is a vast diversity of the length of the day on different planets. Now let us talk about density, which is also a very important aspect, because density and volume gives you the mass, right? So now if you look at this, you say which is the densest planet? Earth. Earth is the densest planet in the solar system. And next comes the Venus or Mercury. And then if you look at the outer part of solar system, that is Jupiter, Saturn, they're big, but they're not dense. Essentially because they consist more of hydrogen and helium, whereas Earth consists of a lot of heavier elements like silicon, iron, titanium, and things like that. And therefore, Earth has the highest density. And in fact, if you look at Saturn, it is even lesser than the density of the water, which is 1 gram per cc. That means Saturn can actually float on water, right? So again, you see a very large diversity in the solar system. And when you talk about the magnetic field, and we know that Earth has a magnetic field which is global in nature and which has a very different kind of structure which provides us a good shield, because magnetic field is actually providing a shield for the Earth. Because of this Earth's magnetic field, you have a huge magnetosphere, which is like a small envelope of magnetic fields, and which saves us from harmful charged particles coming from the sun. And therefore, it is important that we have a magnetic field and an atmosphere to save us and save the life on the planet. Now, if you look at other planets in the solar system, Mercury has a small magnetic field, but then Venus and Mars doesn't have a global magnetic field. It is only the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, which have intrinsic magnetic fields. And there also we have large diversity in terms of the angle between the rotation axis and the spin axis. Just 1 minute. I'll see. I'm meeting. Okay, so let me talk about this magnetic field, which I was just talking about. It creates a magnetosphere, and because of the solar wind, which is coming from the sun continuously, 24/7, with a very high velocity of something like a few hundred kilometers per second, right? They produces a structure which you're seeing on the screen, and this is called the magnetosphere. On the day side, it gets compressed, and on the night side, it elongates, and therefore you have this structure which is actually saving the charged particles coming inside towards the surface of the Earth. And because of this, there is an interaction which is happening in between the atmosphere and the charged particles, and you see aurora. So aurora is nothing but the formation of light in the atmosphere because of the solar wind particles coming and hitting the planet Earth's atmosphere. And therefore, aurora is seen in different colors, and this colors is coming because of the atmosphere around Earth. So atmosphere of nitrogen and oxygen gives you a lot of information about the charged particle coming towards the Earth and producing the sun. So there's a 2 actual shields present on planet Earth. One is magnetic field, and second one is atmosphere. These 2 shields actually safeguard the life on the planet. And therefore, you see aurora on different planets like Jupiter or Saturn you're seeing over here, which is due to the interaction of these charged particles with the atmosphere of Jupiter or Saturn. I will skip all this. Now, let us talk about the composition. Now, we know on the case of Earth, it is largely nitrogen and oxygen, right? So we say about 80% nitrogen, 20% oxygen. But we also know that there are many other gases present, including the greenhouse gases like carbon dioxide, water vapor, carbon monoxide, methane, ammonia, and things like that. But the dominant gas is nitrogen and oxygen. But if you go to a planet like Venus and Mars, you know what they're dominated of? The dominant gas is carbon dioxide. Whereas in the case of Earth, carbon dioxide is a very small in abundance, right? Parts per million we talk. And nitrogen is a very small commodity, few percent. So that means the atmosphere of Mars and Venus is very, very different than that of the Earth. Because in the case of Mars and Venus, is carbon dioxide dominated, whereas in the case of Earth, it is nitrogen oxygen. Now, This slide is a little complicated, so I will not go into details of this slide, but to just look at the top part and say that in the outer part of a solar system, that is Jupiter, Saturn, Uranus, and Neptune, the dominant gas is what? Hydrogen and helium. As I was mentioning, because of which their density is much low, though they have huge size or huge mass. Okay, so that means again, when you talk about mass, you talk about the length of the day, you talk about density, you talk about atmosphere, they are all varying from planet to planet. That's why each planet becomes very unique in terms of its study. We'll skip all this. Now, let me talk a little bit about EO. And what is EO? Let me see. Okay, now you look at this one first. Now, EO is a satellite of Jupiter. And it is smaller than the largest satellite in a solar system called Ganymede. Ganymede is also a satellite of Jupiter. And then comes Callisto, which is also a satellite of Jupiter. And then comes Io and then Europa. And these four inner satellites of Jupiter are called Galilean satellites. Why? Because Galileo Galilei in 1600 itself has seen using the very primitive telescopes. Now, in between, you are seeing Mercury and Pluto size given there. And Mercury and Pluto both are planets, right? So that means in our solar system, we have satellites of planets which is bigger than the size of the planet itself. So this is again a diversity coming. And that makes again the study of the whole solar system or planetary system very exciting. Now let me go back to this slide and talk about EO. Now EO is the most volcanically active body in the solar system. And why volcanoes are produced? Volcanoes are produced because there's a heat inside a body. Now, EO is push and pull between Jupiter and these big satellites called Ganymede and Callisto and Europa. And because of which you have this volcanic activities continuously happening, putting about 1 ton of matter every second. Therefore, this all matter which comes out largely sulfur, SR2, and they populate the whole surface. So EO surface, if you look, it looks like a pizza, right? Different colorations are there, like a pizza. But this is highly volcanically active body, and therefore it is very interesting now to study Pluto to understand the volcanism on a planet. Now let me talk about comparing this largest moons and small satellites. I just mentioned about Ganymede, Callisto, Europa, and Io, which are the 4 Galilean satellites. But if you look at Titan, which is a satellite of Saturn, and that is the second largest. And then comes, of course, Mercury. And if you look at Moon, that is the Earth's satellite, natural satellite, which is called Moon, it is the 5th largest satellite in the solar system. Of course, you are seeing Pluto also over here, or Mercury. But it is very interesting now to see that you have bodies of varying size in the solar system. You have satellites of different planets of different size in the solar system. And then you have different sizes of the planets, different compositions, different spin rates, and different densities. Now, let me talk a little bit in the end about what India has been doing in terms of exploration. When you talk about exploration, you need to have the capability to send your spacecraft or a mission, which you call, to that planet or to that object. And India started its journey of exploration of different planets in the solar system by going to the nearest celestial body, which is nothing but the moon. Now, the word Chandrayaan, Chandra means moon, right? And Yan means spacecraft. It's a Sanskrit word, right? And that's how the word Chandrayaan has come. And if you look at this mission, this was launched on 22nd of October of 2008. And after 16 days of travel, we reached the moon, carrying 11 experiments on board, 3 of them flown for the first time. And it was truly international character because there were 10 different countries participating. And on the right top side, you are seeing this whole spacecraft, where you see the experiment's name in abbreviation, which is basically telling where they are all sitting, because they have to look or they have to observe the different parts of the moon through these instruments. And therefore, the location on the spacecraft is decided by the science objectives of this instrument. Chandrayaan-1, you all know, has discovered water on the moon, which is the biggest discovery. And it has also given us a lot of new information using its different instruments. More than 250 scientific publications has come out from this mission. This you are able to see much better, of course. And the MIP, the gray box which is sitting on the top, was actually released after the Chandrayaan reached the 100-kilometer circumpolar orbit around the moon, and it landed onto the lunar surface on 14th of November 2008, and it made this MIP the first man-made object from India to land onto the lunar surface. I was directly involved in this mission through an instrument called SARA, which you're seeing over here sitting on the top deck. In 2013, we had a mission to Mars, which we called as MOM, Mars Orbiter Mission, or Mangalyaan. And this mission was, of course, a very, very unique mission. First mission from India to cross the Earth's gravity, escape from Earth's gravity to go to the Mars. Because if you look at the moon, moon is going around the Earth, right? So moon is under the sphere of influence of gravity of the Earth. But when you go to Mars, you are actually breaking their barrier and going to the other planet. Now, this mission was also very important and very celebrated mission because India could achieve this mission in its first attempt. That means Indian Mars Orbiter mission was able to be inserted into Martian orbit in its first attempt. No other country has actually got the success. And therefore, this is a highly technologically celebrated mission worldwide because India was able to do it in its first attempt. And it has worked for more than 8 years, though the planned lifetime was only 6 months. It had 5 experiments on board, and all of them have functioned very well, providing us a lot of new information. I believe somebody else may be talking about all these missions, and that's why I thought I will concentrate more on basics rather than talking about different missions. Subsequent to that, we had the Chandrayaan-2 mission, which was much more complex and complicated than the Chandrayaan-1 because it not only had a lander or orbiter like the Chandrayaan-1, but it also had a lander called Vikram lander. And also inside the Vikram lander was the rover. But we all know what happened because during the landing in the first attempt in 2019, it could not succeed. But the orbiter is still working. Even now, as on today, when I'm talking to you, Chandrayaan-2 orbiter is still moving around the moon and providing us excellent quality of data. So that means for the last more than 5 years, Chandrayaan-2 orbiter is still in orbit around the moon and working very well. Okay. Now let me talk about Chandrayaan-3, which is of course a very, very well celebrated mission from India. All of you must have watched the landing of the Chandrayaan-3, which happened on 23rd of August, 2023, right, in the evening. And India made a history. India made a history in the space arena by landing at almost close to the South Pole at 70 degrees south, where no country has landed. And that's why this mission is also very, very technologically challenging, but very well celebrated mission. India could do that. And it is a credit to the whole ISRO community and all the scientists and engineers that we could achieve this mission without any. And not only that, after landing, the rover came out and moved on to the lunar surface and provided us excellent quality of data, which has made several good publications in international journals like Nature. And using this, we now know that there's a large diversity on the moon compared to what we know from Apollo missions or lunar missions, that the moon is not very uniform as we have thought about. There are larger diversities, and the composition has also differences at different locations. So that is only possible when you probe any planet at different location and come to know about the details of the different composition of any planet. So ISRO has been working on various missions, and this is the one which I was just talking about, that we had the landing of the moon, Chandrayaan 3 lander at the landing site. Excuse me. Also, that all the landing so far which has happened is mostly in the low mid latitude, and it is the Chandrayaan 3 mission, the Vikram lander of the Chandrayaan 3 mission, which has landed into the 70 degrees south or near to the south pole of the Aditya L1 mission. I believe has already been told to you by Professor Dipankar Banerjee, and this is also a very excellent mission from India to look at the sun. It is situated at L1 point. L1 point is a point between sun and earth, about 1.5 million kilometers away, which is roughly about 1% of the distance from earth to sun. So that means if you are at L1 point, you are 1% away from earth and 99% away from sun. Okay? And that's why this point is very important, because as the earth goes around the sun, L1 point is also going around the sun. That means you are able to see the sun continuously. You are sitting at the L1. And therefore, this mission, which is working very well, it is working, providing us excellent quality of data, and also continuously observing the sun. The sun is a source of energy, right? And therefore, we should know the sun much better to know what is going to happen in planet Earth, and what are the kind of charged particle which is coming from planet Earth, and how does they modulate and change the environment around the Earth, which we call as space weather. We know the weather, the clouds and things like that, rains, but there's a weather in the space which we call a space weather. Therefore, this mission, Aditya L1, is very important mission for providing us a lot of new information about the charged particles, the flares, the dynamics which is happening on the sun, and how it is affecting the planet. I hope that you would have got a good glimpses of the whole solar system, the exploration which India has been doing. But in future, we are also talking about exploring the moon in a greater detail, and that is through the Chandrayaan 4 and Chandrayaan 5 mission, where we are talking about bringing back sample from the moon. So Chandrayaan 4 is going to be a mission where we go, land on lunar surface, collect some samples, rocks, soil, and then come back to planet Earth and then analyze that collected samples in the lab to learn much more detail about the moon compared to what you can do by sending small instruments on the lunar surface. And similarly, we have a Chandrayaan 5 mission, which is going to be a mission very, very unique, because we are going into polar region. And if you look at the moon, let me see. Okay, let me see this. If you look at the moon, you are seeing these craters, right? But moon, when it is going around the Earth, its axis is almost vertical. And therefore, if you have craters in the polar region of the moon, they will never see the sunlight. So that means they become the deep freeze. And because of this, the temperature at the permanent shadow region of the moon becomes very, very low. It can go down to below 50 kelvins. And therefore, anything which goes and sits, gets there, will be sitting for millions and billions of years. And therefore, we believe that these permanent shadow regions, which are like a dark patches in the moon, particularly in the polar regions, will be containing a lot of ice, water ice. Therefore, the Chandrayaan 5 mission is actually a mission to probe these volatiles present on the lunar permanent shadow regions. And we are also talking about a mission to Venus, to explore Venus, because Venus has not been explored in much more detail. And also, we are talking about having a mission to Mars, particularly a Mars lander. So these are all very important futuristic missions from India, where we are working to explore these planets and to come to know about the much greater details of the planet and their formation, so that we can understand our planet better. I hope you have enjoyed listening to this talk. Thank you all very much.